Okay, welcome back. It's the second tutorial video, and this is your host, Mr. French. That's right, Mr. French coming back at you with a second tutorial video on properties of exponents. So let's continue this. Let's press to see how strong is this ultimate property that makes a lot of sense that we justified with a few specific examples in the previous video. This is property of exponent video 2. So make sure you take a look at that first video. Give me those views, baby. So in the last video we justified this, that we can add the exponents with a few examples we showed. And then we also said that if we want this to be true, then it must be that we're going to have to accept this fact. A to the 0 equals 1. I'm going to be making a more like a crazier video a little bit later on why anything to the 0 has to be 1 with all the different explanations that we talked about in class. But for right now, this is just kind of some class notes that you missed. So we left off our conversation here. A to the 0 has to be 1. So let's take a look at fractional exponents for right now. That was the next big thing. If we can add exponents, let's see what happens with fractional exponents. So I'm going to give you an example here. So maybe we have, let's do 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. So I don't know, like for right now, let's just say that we do not know what fractional exponents equal or what they do, but we do know this. This is the end-all be-all property that we do know to be true. If this is true, then fractional exponents, we would need 3 8 to the 1/3 to equal 8 to the 1st. And we know the value of 8 to the 1st. We don't know the value right now of 8 to the 3rd, but we do know that if this is true, then you can multiply 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3, and you get 8 to the 1st, which equals 8. We know that 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3 equals 8. We don't know what this equals. We don't know what 8 to the 1/3 is. It's kind of a weird thing to think about. But we do know that it has this property. This is the property of 8 to the 1/3. So what is another number where if you multiply it by itself 3 times, you get 8? Two. 2 times 2 is 4, times 2 is 8. So for whatever 8 to the 1/3 is, it has the property that 2 has. So we say that 8 to the 1/3 and 2 are equivalent. They have the same property. You multiply 2 times 2 times 2 to get 8, and this, whatever that is, times itself to get 8. They must be the same. 8 to the 1/3 must be equal to 2. Let's look at another example here. So maybe not to the 1/3 power. I'll pick, and you could probably notice some of the trends that I'm picking with these numbers here. We always get some nice whole number answers. But the concept is going to stay the same. Maybe like, what is 49 to the 1/2? Well, I know that 49 to the 1/2, if this is true, if our property of exponents needs to be true, I know that 49 to the 1/2 has to have the property such that we multiply it by itself twice and we get 49. So then we can get to thinking, well, what other number does that? Because if we can add exponents, I don't know what 49 to the 1/2 is, but I do know that if I multiply it by itself, we can add these exponents to get 49 to the 1st. So what other number multiplied by itself twice? Or I guess, no, multiplied by itself equals 49. So we say that 49 to the 1/2 must equal 7 if we want this to be true. In general, what we're noticing here is that fractional exponents are kind of like roots. Like the 1/2 is acting like the square root. And 8 to the 1/3 is acting, well, if this is a square root, we would call this a cube root. So that's where the expression comes from, that if we have a number to some sort of fractional exponent, it's going to be the nth root of that number. Let's look at another example to kind of justify that. 32 to the 1/5. Now, I don't know what this equals, but I do know that it has the property such that if I multiply it by itself 4 more times, I know that if I multiply it by itself this many times, 1, 2, 3, 4, 5, we get 32 because we can add exponents. So then we got to think for a moment, what other number times itself that same amount of times is 32? And with a little bit of help, maybe a little bit of time, we could figure out that 32 to the 1/5 has to be equal to 2. It's getting very dark. Should get a lamp in here. We'll just deal with it this time. Hopefully you folks can see. I think you can see all right. We looked previously that, like, if we wanted to figure out what 32 to the 3/5. Let's think about that for a second. 32 to the 3/5. Well, I don't know what this equals, but I do know that it has this property. That if we can add exponents, it's 32 to the 1/5 times itself 3 times. But we just justified that 32 to the 1/5 has a value of 2. Because that's the number. Oh, baby! 32 to the 1/5 is 2. Saying is that you're going to multiply 2 by itself 3 times. Another way to write this or think about it, which kind of makes sense, is 32 to the 3/5 is equal to 32 to the 1/5 times itself 3 times. But we know that 32 to the 1/5 is 2. So really, it's just 2 to the 3rd, which is exactly what this says here. And in either case, you get 8. So 32 to the 3/5 must be equal to a value of 8. If you get stuck, what we've talked about, what we noticed was that you can always go back to the addition of exponents. In general, we say this, that a number to the m over n is equivalent to the nth root of a, because that's what we're doing here. We take the nth root, so like the 5th root of 32, to the power of m. That's really fancy notation for this idea here. 32 to the 1/5 to the 3rd power. This is just some extra notation. It's not a new rule. It's not a rule. It's another property of exponents if we want to be able to add them. And we're just doing a stress test on this pattern. I have some practice problems for you to think about. So if you're planning on reassessing, take a look at those videos, and then I would implore you to do at least these 4 problems. Show me that you can do these 4 problems. And if you're all done, if you watch this video just for the sake of learning it again or checking this out, I really appreciate it. And I'm going to leave you with this. So my goal is that I leave you with a question to consider that we may not even know the answer to. But if you have an answer, or if you have some idea, if you can take how we're thinking about this and see, what would you say, if you had to say, what would you say to 0 to the 0 would have to be, knowing what we already know about how exponents behave. All right, thanks for watching.